Hi, my name is Brianna Jenkins, and this is AP Statistics Quideo 2. First, we will start off with the basic question. The basic question reads, the number of people living on American farms has declined steadily during this century. Here are data on the farm population, millions of persons from 1935 to 1980. A. Make a scatter plot of this data and find the least squares regression line of farm population on year. In order to construct this scatter plot, you must put the population in millions on the y-axis and the year by fives on the x-axis. Then you plot your points. According to this graph, the scatter plot is a negative, strong, linear relationship. To find the least squares regression line, you must type in your x and y values into stat and edit into L1 and L2. Once you do that, you go to Stat, Calc, go down to 8, which is linear regression equation. Press Enter, and you get your equation. The least squares regression line equation is y hat, which is the predicted value, equals a plus bx. So the equation would be y hat equals 1166.9273 minus 0.5868x, which is the slope. And you get that from your values in your equation. Part B asks, according to the regression line, how much did the farm population decline each year on the average during this period? What percent of the observed variation in farm population is accounted for by linear change over time? According to your graph in your equation, each year the population of people living on American farms declined on an average of 0.5868 million, which is your slope in your least squares regression line equation. The percent of the observed variation in farm population is found in your r-squared value in your linear regression equation. The r-squared value is 0.9770, rounded up to 97.7% of the variation population. Part C asks, use the regression equation to predict the number of people living on farms in 1990. Is the result reasonable? Why? To predict the number of people living on farms in 1990, you take your equation and put 1990 in for x. After you plug 1990 in, you solve your equation and you get negative 0.80447 million. This result is not reasonable because you can't have a negative population of people on the farm. Next, we will move on to the advanced question. The advanced question reads, manatees are large, gentle sea creatures that live along the Florida coast. Many manatees are killed or injured by powerboats. Here are the data on powerboat registration in thousands and the number of manatees killed by boats in Florida in the years 1977 to 1990. Create a scatter plot of powerboats registered in Florida and manatees killed by boats. To construct your scatter plot, you use the powerboat registrations for the x-axis and manatees killed for the y-axis, going by tens and 50s. A. Describe the direction of the relationship. Are the variables positively or negatively associated? According to the graph, the direction is going up, so the variables are positively associated. B. Describe the form of the relationship. Is it linear? According to the graph, the form of the relationship is linear because when you draw a line through the points on the scatter plot, it goes straight, it does not curve. Describe the strength of the relationship. Can the number of manatees killed be predicted accurately from powerboat registrations? If powerboat registrations remain constant at 719,000, about how many manatees would be killed by boats each year? According to the graph, the strength of the relationship is strong because the points go in a straight line and they are not scattered all over the graph. Yes, the number of manatees killed can be predicted accurately from powerboat registrations because of the strong positive linear relationship. As the registrations increase, the number of manatees deaths will also increase. If powerboat registrations remain constant at 719,000, there will be 47 manatees killed by boats each year according to the data. Lastly, we have the AP question. The AP question reads, windmills generate electricity by transferring energy from wind to a turbine. A study was conducted to examine the relationship between wind velocity in miles per hour and electricity production in amperes for one particular windmill. For the windmill, measurements were taken on 25 randomly selected days, and the computer output for the regression analysis for predicting electricity production based on wind velocity is given below. The regression model assumptions were checked and determined to be reasonable over the interval of wind speeds represented in the data, which were from 10 miles per hour to 40 miles per hour. A. Use the computer output above to determine the equation of the least squares regression line. Identify all variables used in the equation. The least squares regression line equation is y hat equals a plus bx. To get your equation, you take 0.137 from the coefficient constant and plug it in for a. Then you plug in 0.240 for b to get your slope from the coefficient of wind velocity. Your equation should read y hat equals 0.137 plus 0.240x. The variable x is the wind velocity in miles per hour, and the variable y hat is the estimate of the electricity production in amperes. B. How much more electricity will the windmill be expected to produce on a day when the wind velocity is 25 miles per hour than on a day when the wind velocity is 15 miles per hour? Show how you arrived at your answer. To find the difference in the two wind velocities, you take the least squares regression line equation and plug in 15 miles per hour for x. When you calculate this equation, it should be 0.137 plus 0.240 times 15 to give you 3.887. You then take the least squares regression line equation again and plug in 25 this time for x. When you calculate this equation, it should be 0.137 plus 0.240 times 25 to give you 6.387. To find the difference in the two equations, you take 6.387 from the equation used for 25 miles per hour minus 3.887 used for the first equation in 15 miles per hour to give you 2.5. There are about 2.5 more amperes of electricity generated when the wind velocity is 25 miles per hour versus 15 miles per hour. C. What proportion of the variation in electricity production is explained by its linear relationship with wind velocity? The r-squared value found in a regression equation is converted to a percentage. According to this data, the r-squared value is 0.873, so there is about 87.3% of variation in electricity production explained by the linear relationship with wind velocity.